Hello everyone. Now this lecture I am recording with the perspective of ensuring that our students will not only go through the conceptual things which are there in the book, rather than they will relate that particular concepts with the practical thing. That's why today in this lecture I am attaching a binomial tree valuation model, how to do it with the help of the Excel. Okay, till now in the books we have seen that they will provide us a binomial tree and we have to just calculate the price of the bond, price of the asset with the help of the binomial tree. But how that binomial tree we are making, okay, and how we are calibrating that binomial tree, that's the real maths behind. So let us see and understand that how the binomial tree is calculated, how we plot that in Excel, and how to calibrate it with the help of Excel so that you can create your own binomial tree. So agenda is completely clear that I need to ensure a good strong foundation, good conceptual understanding where you can relate the practical concepts with your knowledge which is there in your books. Let us start and move back to our Excel concepts. Clear? So now here you can see that I have a two period binomial tree which is non-calibrated, and I have explained you earlier the meaning of calibrated and non-calibrated. Calibrated means, this means that the tree, okay, the tree which I am using, if I am saying the tree is calibrated, this means that that tree is able to price on the run, able to price on the run securities, correctly. Clear? But if my tree is not calibrated and it is not providing me the amount of the bond on the run treasury security correctly, I need to calibrate it. I need to correct that particular binomial tree. First of all, we'll see how to create the whole structure in an Excel so that whenever I have the inputs, I can put up that inputs in that particular Excel file to ensure that just by putting up those numbers, the whole model will provide me the calibrated binomial tree. Clear? Let us move ahead. Here are some of the values which are already given to us. Okay, here are some of the values which are given to us. The values includes the coupon rate, okay, then the face value of the bond, we have the volatility, also we have the maturity of the bonds. So means I need the full detail about the bond. What are the things I need? I need the full detail about the bonds. Apart from that, I need the details about the spot rates. If I have only these two things, I can create a binomial tree as well as I can calibrate the binomial tree with the help of just bonds and spot rates. Clear? Now let us move ahead. See over here, if you look at this area, okay, this part, I have all the spot rates given. Okay, I have all the spot rates given with me. You can see S1 6%, S2 7, S3 8. What is the maturity of the bond given to us? 2 years. So the amount of information which is important for us is only for the period up to 2 years. Okay, so the period for the third year, the details for the third year is not that important. So means what? I can even delete this third column. This one even I can delete as well. Okay, because sir, this is something which is not needed now, but it will be needed in the future when I'll be drawing a 3-period binomial tree model. 3-period binomial tree model. This is only a 2-period binomial tree model. Clear? So now let us move ahead. First of all, when I have to draw a tree, I need to ensure that I have the spot rates with me. Okay, I have the spot rate, that is 6% with me. Now I have already explained you how to calculate the top node as well as the lower node. First of all, for this I need to find out a forward rate. Forward rate for 1 year after 1 year. how to calculate the forward rate for 1 year after 1 year? It is simple. S2 whole square divided by S1 to the power 1. Then if you'll solve this equation, you will be able to find out the forward rate. And over here I have already given you the forward rate. I have already calculated this forward rate, and this forward rate is actually calculated with the help of a formula. Okay, the whole Excel file is done with the ideology of putting up the formula rather than typing the number, so that whenever in future I will just put up these spot rates over here. Okay, whenever I'll put up spot rates over here 6, 7, it will automatically fetch me the forward rate. If you want to see, I can show you that how actually I am trying to do this. Just wait a second. See over here 6 and 7. Just a second. Okay, now see, for 6 and 7, what is my forward rate? 8.0094. Now suppose I change my spot rate from 7 to say 8. Suppose you see my forward rate automatically got changed. Can you see my forward rate automatically got changed? Why? Because everything is linked with the formula. Everything is linked with the formula. Similarly, over here I am calculating the discounted cash flow. Discounted factor means from this rate I have calculated the discounting factor. How to calculate the discounting factor, if you remember? If I want to know the discounting factor of this one, how to calculate this? Tell me how to calculate this. It is going to be, okay, I think some error with the pen. Yes, now it's fine. So it is going to be 6 divided by, sorry, it is going to be 1 divided by 1.06. Clear? And when you will solve this, you will be getting this value 0.094. How to calculate the discounting factor for 7? It is 1 divided by 1.07 whole to the power square. How to find out this discounting factor? This is nothing but 1 divided by 1.08 whole to the power 3. So means everything step by step I have calculated this. Are you getting the point? First of all, I started with the spot rate. Then I started with the forward rates, and then I entered into the discounted factors. Why I have calculated this discounting factor? Because I need to calculate the present value. You remember what we have to do? First of all, we have to calculate the price of the bond. First of all, we have to calculate the price of the bond with the help of DCF method, that is discounted cash flow method. So the sum of the present value of the cash flow, is the price of the bond today. Now what is my cash flow? You can see over here my cash flow. If the bond is of 2-year maturity, in 1 year I am going to get 80. Why? Because if you'll see the coupon rate, coupon rate is 8%. You can see the coupon rate is 8%. Face value is 1000, maturity is 2 years. Means I am going to get, what I am going to get if I am drawing a timeline starting from 0, 1 and 2. So over here I am going to get $80, and over here I am going to get $1080. So these are the two cash flows for me. So the sum of these two present values, I have actually mentioned over here. Sum of these two present value I have already mentioned here. Okay, let me, what it is opening. Yes, so you can see 1018786. This is, you can see the sum of these three values, where the third one is the 0. So this is nothing but the present value of the bond. Okay, so over here you can mention that this is nothing but the present value of the bond, or you can say price of the bond, or you can say the price of the bond at which it is trading in the market. And this is 110% correct, because the DCF method is accurate one. For the straight bond, But now I want to draw a binomial tree. I want to draw a binomial tree, and with the help of the binomial tree also I need the same price. Because if the binomial tree is giving me a different price, this means what? This means what? The binomial tree is wrong. Because this is 110% sure that 1018.786 is the correct price. No one can ignore that. Clear? So now from here onwards, our target is to ensure that we are going to create a binomial tree. Okay, we are going to create a binomial tree with the help of the spot rates, with the help of the spot rates. Clear? Now if you remember how to create a basic binomial tree, how to create a basic binomial tree, 6, then we have a forward rate. Forward rate is 8%. Forward rate is 8%. Now how to calculate? How to calculate the top node and how to calculate the lower node? So from the forward rate, it is e to the power sigma up and e to the power sigma down. From 8% it is e to the power sigma up and e to the power sigma down. That's the volatility of the interest rate. What it is? It is the volatility of the interest rate. Now volatility is also given to us. You can see our top box. What is the volatility? 0.15. The volatility is given to me. Now what you have to do? You have to find out that from 6 how much it can go up, from 6 how much it can come down, from 6 how much it can go up, and from 6 how much it can come down. But there is a barrier in between, that is the forward. So it is saying that from forward it can go 1 sigma up, e to the power sigma up and e to the power sigma down. So now how to find out the top node? How to find out the top node? Simple. It is going to be 8% multiply with e to the power sigma. What is the volatility? 15%, 0.15. Clear? Similarly, if you want to find out the lower node, how much it is going to be? 8 multiply with e to the power negative 0.15. So means you can find out the top node as well as the lower node. Clear? Now, if you will see over here, if you will see this side, the red color box, lower node as well as top node. I have calculated this with the same formula. I have calculated this with the same formula. You can see E13. E13 is what? My forward rate, and then exponential minus K8. K8 is nothing but the volatility. K8 is nothing but the volatility. So e to the power x, but it is negative. It is negative. Why? Because this is the lower node. In upper node, if you will see, it is exponential K8. There is no negative sign. Clear? So till now we all are good with the top node as well as the lower node, which I am calculating from the forward rate. One more important concept. Let me take you over here only. That is, if this is 6, this is 8, this is 9.30 and this one is 6.893. Okay. Now this gap is e to the power negative sigma and this gap is e to the power positive sigma. So means the gap over here is sigma, the gap over here is sigma. What is the gap between 6.893 and 9.30? That gap is e to the power 2 sigma. That gap is e to the power 2 sigma. Means if suppose I will be telling you and you calculate it in your calculator, you will see that 6.893 multiply with exponential 2 multiply with 0.15. No negative sign. Why? Because I'm going up. So while you are going up, no need of negative sign. When you are going down, there is a need of negative sign. When you will solve this equation, you will see that you will end up on 9.30. So means what? Try to understand. From the forward, if you go 1 sigma up, you will reach the top node. From the forward, if you will go 1 sigma down, you will reach the bottom node. But from the bottom node, if you want to go to the top node, the gap is sigma. That means 2 sigma. Clear? E to the power 2 sigma, and you will reach from lower node to the top node. Clear? So try to digest whatever I have covered till now. Let us take it again. I started with the basic detail of the bonds. I started with the basic details of the bond, and then I told you I need to have the spot rates. If I have the basic detail of the bond and I have the spot rate, I can calculate the present value of the bond. So means, can I say that I can write you some steps? First step is the present value of the bond with the help of DCF method. This is my first step. Now let me reach to the second step. What I did, I calculated the forward rate, because without the help of the forward rate I cannot create a tree. So once I have the forward rate, I can create a top node as well as lower and top node, lower node as well as top node. These two I can create with the help of the forward rate. Now when I have the top node as well as when I have the lower node, I can create a binomial tree. You can see over here, you can see starting from 6, reaching the top node, and then this is the bottom node. So means I have top node as well as the bottom node. Clear? I'll come back to other details, but till now I think you can digest whatever we have covered. Clear? Let us take our discussion ahead. Now our task is from here to find out the present value, the price of the bond with the help of binomial tree. See over here, what is my second step? What is my second step? Price of the bond, write down price of the bond with the help of price of the bond with the help of binomial tree, This is something which I really need to find out. Clear? So while doing so, I need to create a tree. I need to have the details of the cash flows. When I have these two things, in order to find out the present value of the bond, what you need? Sir, I need two things. First of all, I need to have the details of the cash flow, and second, I need to have the details of the interest rate. When I have these two, I can pull up the cash flow. I can pull up the cash flow with the help of the interest rate. Clear? Okay. So I have the details of cash flow. What are the details of cash flow? First of all, if I draw a timeline, 0, 80, and over here you have 1080. Please try to satisfy. This is the time 1, this is the time 2. This is the time 1, time 2. So now, can I write over here T0, T1 and T2? Now, this 1080 will be discounted with the help of these two rates. Why? Try to understand, 1080 is something which is available in the future, and you want to discount it 1 year back. Means, try to understand, you are standing in 2020. The cash flow is in 2022. You want to discount it back in 2021. You are standing in 2020. Let me write down over here. 2020, 2021, 2022. A cash flow which is going to come in 2022, you want it in 2021. What is the present value of that cash flow in 2021? Clear? And you don't know the interest rate, because try to satisfy yourself. After 1 year, what will be the interest rate for 1 year? No one knows. After 1 year, what will be the interest rate for 1 year? No one knows. Forward rate is something which you fix today, but the expected spot rate, or you can say the spot rate on 2021, spot rate on 2021, this is something which no one knows. Clear? So they said that there are two possibilities, that the interest rate can be 9.30, interest rate can be 6.839. Then there is a confusion, by which rate should I pull 1080? Whether should I pull it with 9.30 or 6.893? So they said that pull it with both of them and then take the average. They are trying to be very sincere with that. They said that, okay, pull 1080 with 9.30, pull 1080 with 6.893, and then take the average of that, so that you are giving equal probability to 9.30 as well as 6.893. Clear? So now, what will be the next course of action from here onwards? The next course of action is to discount these values. Discount these values means, what is my value? You will see 1080. 1080, you need to discount it at the rate of 9.30, and after discounting it, you will be getting this value. Similarly, you will be discounting at this rate and you will be getting this value. So means, now can you say that I can find out the present value at 2021, but these present value are giving me two different data. One is 988 and another one is 1010. But what we have to do? We need to take the average of these two value. We need to take the average of these two value. So the average of these two value, is going to be, let me write down over here. What is the average of these two value? Just a second. Yes, the just a second. Okay, the average of these two values are 999.202. So means the average of 1080, which is standing in 2022, which came to 2021, its present value. Now remove the word average. Its present value is 999.202. Now you will be getting a cash flow of 80. You will be getting a cash flow of 80. Over here. So what is the amount which will be discounted? So write down 999.202 plus 80 divided by 1.06. So the answer is giving over here. That is 11018.115. Clear? Now you shocked that by doing so much, but the answer which is given by the binomial tree is little different. What was? It was 1018.786. So there is a very small difference, but yet there is difference. So now you need to calibrate the tree. You need to make your binomial tree correct. So what you have to do in order to make your binomial tree correct is, you need to take the help of the Excel tool. Clear? So now let me rub all these details so that I can take the discussion ahead. So now one thing which I am sure, that now my tree is not correct, I need to make it correct, I need to calibrate it. So in order to do the calibration, try to understand which rates you can change. You can change only these two rates, because 6% is something which is fixed. You know the interest rate today for the period of 1 year. So there is no point of changing these two interest rate. So now you need to link this interest rate with this interest rate. How come? 6.893 e to the power 2 sigma. So if I'll show you that I have actually linked 9.30. You can see I have actually linked 9.30. You can see J26, that is 6.893 exponential 2 multiply with volatility. So means if my 6.893 will change, my 9.30 value will change automatically. Clear? If the rates will change, the amount will change automatically. If the amount will change, the average amount will change automatically, and the amount over here in this box will change automatically. Clear? So now our target from here onward is to calibrate the tree. So there is a process to calibrate the tree. First of all, I'll write down the process and then we'll take this discussion ahead. First of all, you need to go to the data tab. Then you need to go to the what if analysis, and then you need to choose the option of goal seek. Clear? What is your goal? My goal is to make this 1018.786. Are you understanding the word goal seek? What is my goal? I need to change this amount to 1018.786 by changing these two interest rate. Clear? So how I am going to do this? That is something which we need to understand. Clear? Okay. So now let us start step by step. First of all, I need to go to data, then I need to go to what if analysis, then click on goal seek. First of all, you can see set cell. This is the cell which I want to change. What is the value I need to put over here? 1018.786. By changing which cell you want to change? I want to change this cell. Click on OK. After doing all the trial and error, a table is in front of you. A binomial tree is in front of you, which is now calibrated, and you can see this table is giving you the value which is same as our tree which we have done earlier. Clear? Hopefully you are understanding till now. The concepts are clear till now, that what we have done and how we have done. That's the simple way of creating your own binomial tree, your own models, and creating and calibrating your binomial tree. Agenda satisfied that yes sir, now I am well versed with creating my own model, with creating my own binomial tree and calibrating it. Clear? I always suggest to all the students, not only focus on the bookish knowledge, try to take something additional. Okay, something extra will make you extraordinary. Otherwise, you will remain ordinary for the rest of your life. Okay, so with this, I am ending this lecture. I have explained you a two-step binomial model. Similarly, we can create a three-step binomial model. Okay, I am ending this lecture here. Thank you.